Today, the key things that we're gonna cover is we'd like to introduce you to Pall, who we are, what we do. You've probably seen our building as you if you've driven in and out of Portsmouth. We're going to go on a bit more into sustainability and how we approach this at Pall. I know this is something which you've been working on at the college, and something which we were asked to just highlight how in industry we apply different techniques, and what sustainability means for us. We'd like to just talk a bit about the STEM skills that we'd like to see, and then similarly, we'd just like to show you some of the roles that are available at Pall, both at undergraduate, but then also if you've graduated as well, or if you've got different degrees or different qualifications along the way. So giving the talk today is myself and Emma. So I am an MPD program manager at Pall Corporation. So currently I'm working within the medical R&D, which is a research and development team. But my previous background before this was a master's in medical engineering, but also a lot of research and development and project management. So I worked within the biopharmaceutical industry before, still working for Pall, but within a different sector, and had lots of opportunities to develop new products, to integrate new products, and understand how our products actually make a difference with people in the world, and how our filters and products are used. So Emma, if I hand over to yourself.
So hi, I'm Emma. I'm on the Research and Development Leadership Programme, so that's one of the graduate schemes that Pall offers. I'm relatively new to the company. I'm getting my foot in, but I have my background is a master's in medical engineering. So yeah, I think that's all from me. So just to introduce what Pall is as a company, and it's probably best to start where Pall fits in. So Pall is a relatively large company and was bought by Danaher several years ago, forming what we call an opco. So Danaher own multiple opcos across 3 distinct platforms. That's life sciences, diagnostics, and environmental solutions. And the largest funnel of revenue for Danaher comes from the life sciences division. But across all the divisions, typical total revenue for Danaher amounts to 19 billion, and I think that was the value for 2019. Pall sits at, more specifically, the key areas within Pall fit within the life sciences division, and I will break these areas down more in later slides. But the important point to make here is that once you are within an opco, there are opportunities to move or translate across to work in other opcos in any of the divisions if that's what you desired, but ultimately still within the Danaher company structure. Next slide. And diving into the history of Pall a bit more. So it was founded by Dr. David Pall in 1946, where we produced a single product, and the company has since expanded into becoming a global leader in filtration, separation, and purification. The products that Pall produces are used in a variety of different applications. So that could be biotech, laboratory, filters in aeroplanes, and even which I find personally very interesting is that Pall had air filters on the spacesuits for this first space landing. And I can go on, but I think the image in the next slide will show you nicely the range of products and devices that Pall that have Pall products within it. So you've got the switch, some calculators up to electric vehicles, satellites. It's all very broad. And I think the reason why Pall appears in these variety or these various products is because Pall, or the people who work at Pall around the world all have the same drive to solve customer challenges in the fields of filtration, separation, and purification. And the customer challenges themselves are often very diverse. But ultimately through this, Pall is able to advance health, safety, and environmentally responsible technologies. So looking into the areas of focus within Pall, it is split into two sectors. So you have the industrial side of the business and the life science side of the business. On the industrial side, it covers aerospace, microelectronics, food and beverage, and FTAP, which is filtration techniques. And then if you look over to the life sciences side, it's broken down into laboratory, biotech, and medical. And across all of these areas, there's possibilities for undergraduate roles and graduate roles. So the next question might be, where would you find Pall? And there are Pall sites all across the world, whether they are manufacturing sites or commercial offices, for example. At Portsmouth, they have their Centre of Excellence. So here you'd find well, here's where a lot of R&D work is carried out on a variety of different products, whether it's maintaining existing products or developing new ones. And it's also home to SLS, which stands for Specialist Laboratory Services. And then there are manufacturing sites in Portsmouth, Ilfracombe, Newquay, and Redroof. I actually know someone who's working at a manufacturing site in Newquay and has now moved to a manufacturing site in Belgium. So there are opportunities to move around if and when required. But this also goes to show that we work alongside a diverse range of people all across the world, and you get to collaborate with them and learn from them. But the most current thing that has affected everyone's lives is COVID-19, and Pall has played a big part in bringing the COVID-19 vaccines, the AstraZeneca vaccine, to the market in a time-efficient and definitely time-critical manner. So Pall products are used throughout the process, and the experts from Pall assist with the use of the technology that is used to scale up the production of the vaccine. So an example of this is the single-use technology bioreactors. So bioreactor allows a few number of virus particles to reproduce themselves into billions of cells. And ultimately, this reduced the time to market from 5 years to just a few months. And now I pass you over to Peter, who's going to talk about sustainability at Pall.
Thank you very much. So if we were to slightly change how we would do this presentation, if we were to do this in person, I'd ask what we think sustainability is, and almost, why we think it's important. But instead, I went to the dictionary, I Googled, and I looked at what sustainability is. So sustainability, as per the Oxford English Dictionary, you can see on the screen, is the property of being environmentally sustainable, the degree to which a process or enterprise is able to be maintained or continued while avoiding long-term depletion of natural resources. Essentially, the way that we look at it, and the way that we look at it at Pall, and the key reasons why we think it's important is, the whole point of living sustainably is to improve the quality of lives. We want to protect different ecosystems and then similarly preserve natural resources. It ties us back to that vision and mission, which was shown, that Emma showed a couple of slides back, about how we want to be able to support our customers in the best way. And this is one of the ways that, we feel it can be approached. So in terms of how Pall approach, there's almost two separate approaches for how we at Pall can be more sustainable. So the first one, which we'll look into in a bit, is all about how we've added sustainability to the new product development process. So as Emma said, we create products. We have products that are used in a variety of different systems. We've got filters that are used in hospitals to treat burns patients and for anesthetics. We've got filters that are used within the biopharmaceutical process. But we've also got machines that are used from a variety of different areas, and actually that harness the filtration that we've got. So within this, the market is evolving. Everything is always, technologies are evolving. And as a company, we need to continue to develop products to ensure that what we offer is what the market needs. And similarly, there's no gaps. So this is where we go through an MPD process of creating new products that will fill the market needs, and that at the end of the day, the customers will use to be able to, for whatever their processes are. But then similarly, we look at sustainability from a company level. So how can we as a company reduce our carbon footprint? How can we reduce the amount of water we consume? And actually, how can we as a company become more sustainable? So I've put a link at the bottom here for the Danaher Sustainability Report. So one of the things that large companies are doing now is, as well as their annual reports where they report out their finances, they also share with the shareholders what their companies are doing in terms of sustainability. A lot of the larger companies, the drug companies, and what they tend to do is they've got sustainability pledges where they would like to be carbon neutral by X amount of time. And what we find with customers and shareholders is they want to know how Pall is approaching sustainability so it fits with their vision and mission as well. So we need to share to everyone what we do in terms of sustainability, but then also we need to live it. So the first thing I'm going to touch on is the MPD process, and typically just give you an understanding of how we approach the MPD process and then how we can be more sustainable within the product development process. So on the screen is almost what you'd expect a new product development timeline to be like. Very crudely, you start with a problem, you've got an idea, you go through, you look at that idea, you design a prototype, whether this be out of, whether this be out of card, whether this be out of the final material. And then once you've got that and it's been approved and it's met the requirements from your customer, then you go and you'd have a final concept. This final concept you'd test, you'd make sure that it does everything that it needs to do. And then similarly, you'd look to transfer it to manufacturing. Once you've manufactured it and you've got a large amount of quantity available, you do your final test to ensure that from manufacturing that it still lives up to the requirements, and then it would launch. So this is very crudely what you'd expect from a new product development timeline. And in an ideal world, it would all be linear. You'd start with an idea, you'd look through the idea and design and prototype, and hopefully the first design you have ticks all the boxes. However, that's not the case. The diagram on the next page is probably more realistic for what we see from MPD timelines. So this is a design squiggle change curve. So the bit on the left is almost where you start. So you'd start with the same problem on the left-hand side, and you'd think you'd come up with an idea, but then actually there's lots of research and lots of development that needs to go into it. So you need to spend a lot of time prototyping, reviewing with customers, thinking about new ideas. So there could be lots of different ways that you could approach a solution. And what you're doing within this area is finding out the best way of approaching it. So whether this be with filters, you need to understand, if it needs to be a certain construction or it has to have certain limitations, there's different ways it could be there. For example, if you're looking at effective filter area, so the amount of filter material you've got within a fluid or within a filter, you could change the length and the height and have a ton of different sizes that you could test. But if you were to test all of them, you would then go through and you'd have to make lots and lots, and actually that would result in lots of waste. So what we're doing at Pall is we are trying to look at how we can take this from the learnings we've got from the MPD and the understanding that the prototypes will need a lot of work. There's going to be lots of concepts. We're going to have to review it in different ways. And there's an understanding about, okay, how can this be applied to try and make it more sustainable? So as I touched on, prototype testing, typically you go through several different different iterations of your product. So as you go along the design cycle, and hopefully this is something that you'll have seen before, the design cycle is very much identify the problem, think about different ways you can approach it, prototype different ways. This could be different ways. And the thing about prototyping is it's very unlikely that your first time will be the best way to do it. You'll learn a lot, but actually, and this is one of the things that we promote within R&D, is fail fast. If something's going to fail, then understand it, prototype it, test it, and look at it and understand what can I do or how can I change this to make it better. And that leads on to different prototyping, different iterations, and you can understand if you're producing something and you need to have, say, 30 filters to make it statistically significant so your tests come in. If you do 30 filters and then you do 10 iterations, and that's 300 filters you have to make. And actually that will then get refined over time, but you're continuing to make lots of filters or make lots of prototypes. So what we need to understand is what can we do prior to any physical prototype testing to look at being a bit more sustainable, so reducing the amount of waste that we use. So within our product development system, we go through a couple of different ways where you can approach it. The first one is actually the use of FEA. So when it's applicable, FEA is finite element analysis. So this is when we use computational models and we simulate the different requirements that we need. We can do fluid requirements, we can look at the stress of different components. If we're making something that has to hold up to 2,000 litres on top of it, we need to ensure that prior to building anything, that the design that we have made can hold the weight. So we can use computational analysis to look at different stress points to understand if the materials we've selected will be correct. And then we can also look at, and we've designed in-house, looking at, okay, if we're doing a filtration device and we look at different membranes or we look at different constructs, will that meet the different requirements that we need? So that's almost the first way that Pall is trying to reduce the amount of waste in prototyping. By FEA and by using the computational analysis, we can limit the need for that design cycle of prototype testing, because we can almost cross out some of the designs before we even come to produce them. Similarly, what we can do is we can use recyclable materials and reusable materials for prototyping. You can see here one of the things that we were designing. So this is for a buffer management system, which is used within the biopharmaceutical process. And these devices sell for about £250,000 each. And what we needed to do is we were looking at these different devices, these doors, and trying to understand, okay, is there a certain way we have to open it? How can we make it so the user, where do we put the hinges so it's easy for the users? Are there any health and safety points within this? So for example, some of those at the top, if we were to lift them up, could they fall down on someone's fingers? If that's the case, where do we need to put the hinge? So doing a lot of this prototype testing can actually answer a lot of questions. However, what we are trying to do at Pall is reduce the amount of waste that is used. So not only do we look at it during the prototyping stages during this process, but we also look at it as we go through when we incorporate it into the new products. I highlighted earlier that one of the things that we like to do is we like to try and incorporate it throughout the whole process. And when we transfer it to manufacturing, similarly, we want to try and make this product as sustainable as possible. So how we approach it is we optimize the product design to limit waste. So there are various number of techniques about how you can make new products. So depending on the type of product, depending on the quantity, you can use different molding techniques, you can use different materials. And this is all about how we approach our designs and making sure that the designs work in such a way that this is incorporated. So when we design different cages, different cores, or different plastic materials, if we can injection mold it, which is that image on the bottom, we've got to make sure that the design that we've got is available for molding. So we want consistent wall thicknesses, we want no gaps, we want all of the material to be able to cool at the same time. Depending on the technique you choose, almost helps you limit waste. So if you use that injection molding one, then there's a small amount of waste. But then similarly, if you use something like this top machine we've got here is a CNC, and this has taken a large chunk of metal and it's taken it down into the smaller set. So it's all about understanding, okay, if we've designed it like this, that it has to be machined in this certain way, is there a way that we can optimize it so it doesn't have as much waste? You can see even from that photo, there's hundreds of different, different sparks or different waste material that's going off. And yes, it can be recycled, but if we can limit that, then it's almost better for what we can do for the, for us as in how our new products are sustainable. So we also use recyclable materials where applicable. This isn't always the case, or we're not always able to do this with our products because of the cleanliness, but where we can, we try and use them as much as possible. So this has been a big initiative at Pall, and it's something that we've been trying to bring in more and actually bring it as more of a value for all of the new product development that we complete. So we've got specific people who work on this. We have sustainability champions, and you can see this is almost the journey that we want to take. So we've started from not having a mature level of sustainability commitment. And actually, I'd probably argue we're in the stage at the moment of going from stage 2 to stage 3, so those dots. So we've started to look at our companies about how we can limit waste within and promote sustainability within our facilities, but also we're trying to understand, how we can do this in terms of the new product development. So we're starting to look at this. Whenever you go through any new product development, you have to go through what we call a stage gate process, and essentially it's all of those ticks, like what I showed on the new product development roadmap earlier. It's gates in there to ensure that your key deliverables have been completed prior to launching the project. So what we are trying to do is we're trying to implement sustainability within this process. So that thinking that I was highlighting before about, can we use computational analysis rather than physical analysis to analyze this? Can we make it out of material that's more, available or more recyclable? Can we make it out of, products or have we made the design limit waste as much as possible? So we're trying to organize it around sustainable innovation, and innovation is a very important thing. And so you can see we've still got a longer way to go to continue to mature how we progress our sustainability. And the key things that we're looking at the moment is how we're implementing this within the product design. You can see some of those bits on the screen. I won't read over it. But we want to continue to reduce our implant costs and also the impacts. And it leads on quite nicely to what we can do in terms of what Pall do in terms of the environment and our facilities to try and promote sustainability and to try and make our company as sustainable as possible. So in terms of a company perspective, we've looked at it from the new product development, but in terms of the company perspective of the environmental impact goals, we've set ourselves as a company these impact goals. So in terms of energy, water, waste and emissions. So we set the baseline in 2019. We saw where we were, and then we looked at what we could do in terms of reducing this by 2024. So energy, we're looking for for both energy and water, we're looking for a 15% reduction. Well, for all, we're looking for a 15% reduction But what I'd like to show you over the next couple of slides is actually how we've been approaching this since we started this in 2019. I'll start with water because just due to the production processes that we have and the products that we make, water is a huge driver for us. So within our Pensacola sites and Beijing sites, within all of our filters, there's media. And by media, we're talking about different membranes. And what this does is this is what acts on the inside as the filter for your filtration. So depending on the size of the filtration membrane that you need, we've got some with pores of 0.2 microns. So incredibly small, but these are virus filters that take away the viruses. The production process for all of these go through significant amount of water. So because it's a cooling process, it's a heating process, you have water to react with the different components we've got within it. The media is an incredibly important part of our business. It's something that we need to do and something we will continue to do. But what we're doing is we're starting to look at how we can reuse some of that water so less is wasted. You can see on the screen we use 2.5 million meters cubed of water every year, and it costs approximately $5 million just for our water consumption. And most of that, as you can see, is on the media site. So one of the things that we're actively looking at is we're trying to understand what we can do in terms of the water treatment to reuse the waters that's used within those membrane processes. So the left-hand side of that photo is an untreated water. So this is the water that comes off of the media line after we have started to produce it and after we're going through the process of producing it. And on the right-hand side is obviously the water that we all want. We want clear water. We want it to be, we don't want it to have any impurities in, and we want it to be able to save to reuse again. So what we're looking and what the ultimate goal is to be able to reuse the water, and we've got teams working on it and how we can, in those areas of high stress where potentially the water's not as available, what we can do to reuse the water, particularly in the manufacturing side, to limit our usage. So if we look at electric goals as well, the company have ensured that 100% of the fleet across the EMEA, so that's the Europe and the Europe market, is transitioned to fully electric cars by 2030. So all associates will start to, all of the vans and the different vehicles that Pall use will be fully electric across Europe. But then also something that's been started to drive out or driven out is the use of electric cars for employees. So we've got different salary sacrifices schemes, different areas where you can become or you can get an electric car, which hopefully encourages the use of electric cars rather than what we're using currently. We're also looking at solar panels. So as most manufacturing sites and schools and colleges, we do use a lot of electricity. We use a lot of monitors, we use a lot on, just general lights, and we're trying to look at and we're trying to understand about what we can do in terms of renewable energy to power the plant. You can see that Milan has solar panels on the roof and 12% of the energy comes from renewable energy. We've got a site down in Ilfracombe where we're starting to look at putting solar panels on the roof, and the solar panels are now on the roof. And what's starting to happen now is these manufacturing sites are able to generate the energy themselves and then use it within the electric used within the consumption of the site. So one of the other things that we're looking at as well, we've got 4 sites that currently we do not send any waste to landfill. So here at Harbourgate, where we are, our manufacturing sites in Ilfracombe, none of our waste goes to landfill. So we recycle as much as possible, and then the rest of it go off and is disposed in different ways. So none of it's gone to landfill. We're also looking about how we can use different materials for for different purposes. So one of the things that I found really interesting was there's a new walkway installed on our Newquay site, which is made entirely out of recycled plastics. So the plastic straws that should have been heading to landfills, they were recycled, and actually they were able to be produced into these pellets, which is now our walkway at our Newquay site. And because of the makeup of the straws, it allows the water to filter through. And for me, I thought this was a brilliant use of showing how we can use this, like plastics, which are not biodegradable, and use them in a sustainable way. We're also looking at reusing customer filters. So some of these filters are more on the industrial side, and you see these in aeroplanes and different areas that it could be reused. So what we're looking at is we are asking customers to send back specific filters rather than buying a new one. Send back specific filters to us where we can clean it, and the metal filters, we can reuse them up to 5 times. And as it says here, this eliminated CO2 from transport by 80%. So as a company, sustainability is something that Pall is really pushing, and I think it's going to be a key driver over the next coming years. So it's incredibly important that we all have the mindset of what we can do to be more sustainable. And just looking at this, I had a quick search the other day of what jobs are available, and at the moment these two are just for Pall. So you can see the sustainability coordinator, a sustainability engineer. But just a quick search into the Danaher website, which we'll go on to later, there's 44 jobs currently about sustainability, and this is very much still in its infancy. So if there's something, if sustainability is something which you really enjoy, it's only something which is going to be more and more required over time. So definitely it is important. It's going to be important within our everyday work, but also just as a company, I think it's important. So continue with the sustainability. I think we'll go on to the next part, but if you have any further questions on sustainability, then feel free to ask at the end. But it's incredibly important, and it's something which we as a company are passionate and getting more passionate about. So moving on from sustainability, it's one of the things we'd like to highlight is, as an employer, and what you can do, or what STEM skills we would like to see in terms of, if you were to come to interview, if you were to come and work for our company. We are a STEM company. Yes, there are non-STEM roles, but typically we are a STEM company with a lot of science, technology, engineering and maths roles. But what are the skill sets that you need? So I will admit that this has come from the STEM Learning website, but you can see what we're looking for is, we're not looking for so much, we need you to have these type of qualifications, or you need X, Y, and Z. Yes, we would like you to have a STEM subject behind you, engineering, accountancy, any technology, sustainability. But actually, the key things, or the key skill sets that we look for, are how you are as a person and how you work with others. The technical side of the different roles, they can always be taught to you. I joined this company having no idea how filtration worked. I joined the pharmaceutical side, or the biotechnology side, not understanding the process. There's different processes you go through in drug production. I hadn't seen any of these before. I didn't understand it, but these are all the things that you can get taught. You don't have to be an expert in something before you join a company, but what you have to be able to do is you have to be able to, get along with others, and also show the motivation that you're willing to learn. So they're broken down into 3 different key subjects. So the first one is all about how you work. And you can see here, this is all about what organisation skills you've got. Do you enjoy working under pressure? do you adapt your learning? And similarly, are you self-motivated? So these are all skills that you can use and that you have, and I'm sure you use through your college as well, and anything outside of college as well. So one of the key things we'd like is, if you're given a task, then do the task, think of different ways to do it, but then think beyond the task as well. If you're asked to do a certain bit, understand or ask questions for how it fits into the next stage. And then if there's something you can do further or the next part of your task, then showing that you're willing to think ahead and that you're willing to learn, it's incredibly important. Working under pressure, we're always under pressure. A lot of what we do is, even with those new product developments, we set ourselves timelines. There's different timelines you work to. We have different swim lanes, which are different owners of tasks. And a lot of the time, one task will depend on another. And we get judged, or we have speed to market. We need to make sure the products are released at certain times and processes are completed. So it's all about what you can do and making sure that you are able to get your work done. Similarly, the next bucket was all about how you work with others. And this is all about teamwork, communication, and this is it. We are a big team here. So everyone and all companies, you have to work together to get projects through. So you need to be able to communicate different issues and also or communicate the different technical skills that you're working on. So the rest of it, as I say, we can teach you about this. And if you have any further questions on this, this is taken from the STEM Learning. I can send the poster to you, and it highlights some of the different areas about how you can develop. But have a think that really the key skills that we're looking for are how you are as a person, how you work with others, and then how you think. In terms of the technical skills, that can be taught to you at whatever role you're in. So thank you very much. I'm going to pass back over to Emma.
Thank you. Thank you, Peter. So within Pall, we have apprenticeships, undergraduate placement opportunities, graduate schemes, which are broken into two different schemes. We have the Research and Development Leadership Programme and the Operations Leadership Programme, and then we have graduate roles as well. So in regards to the undergraduate placements or internships, so this is usually when a student would, in the second or third year of uni, or maybe the third and fourth if they're doing an integrated master's, would go and undertake a placement year out of uni. And Pall would typically have roles within or across these departments in the UK. So we have aerospace, biotechnology, technical, inside sales, laboratory, R&D, bioprocessing departments that you could be involved with. And in the year 2020 to 2021, Pall was rated within the top 65 medium-sized placement schemes. And this is because Pall has been putting a lot of focus and attention into looking at developing the placement schemes more, making sure that there's opportunities in place and the quality of the placement schemes are good, so that the student would like to come back and work for Pall, but ultimately give them the right set of skills for any future career that they wanted. And within this, there's a lot of support and training that is given. And again, just to reiterate, it just gives you a lot of valuable experiences that can help you along in your future careers. So yeah, as previously mentioned, there are two graduate schemes. So you have the Research and Development Leadership Programme, so we call it the RDLP. And at the bottom is these are the people who are currently on or have graduated from the RDLP, and there are RDLPs in the UK and in the US. And it's worth saying that a lot of people who have graduated from the scheme have gone on to further jobs within Pall upon graduation. So Peter's a very good example of that, where he was on the scheme and has now graduated and gone on several roles within Pall. And the RDLP is formatted through 4 6-month rotations, usually within various departments, but within one business unit. So that could be 6 months in new product development. It could be 6 months in manufacturing, could be a project management role, testing roles. But it's ultimately designed to help and give you an understanding of how the processes within the company work to form new products or inspire new ways of doing things. And within the scheme, there's 2 times a year, there are summits which you can go to and you share your experiences with other RDL peers and give presentations. And these are held in the UK and the US. So there's opportunities to travel there. So the other graduate scheme is the Operations Leadership Programme. And for this, the candidate needs a bachelor's or master's or advanced degree in engineering. And the programme is designed for those interested in working within operations or manufacturing, but they also have to have a strong passion for leading people. And with this scheme, you're typically based at one manufacturing site, which was previously mentioned in the slides. And you'll be there for 1 year, and then you might move to another site for the second year, and that could be in a different country, but it allows you to gain a wide variety of skills across different job roles during that scheme. And here's just a list of the open roles currently at Pall, and includes remote working. Obviously, due to COVID, that's become a new thing now. And what's also mentioned on the slide is the corresponding job advert numbers or the job vacancy numbers, which I will refer back to in a moment. So if you would like to apply, you can apply through the Danaher Careers or Pall.com. And if you look for search careers, you should be able to find the type of role you're looking for and where the vacancies are available. So the example shown here is for the RDLP scheme, but it'll be the same process for the OLP, undergraduate roles, graduate roles. And you can also search using the job vacancy number that was previously mentioned. So once you have found what you are looking for, what job appeals to you, then you start the application process, which is done through an online portal, where you'd start by uploading your CV. Oh, and I suppose that brings us to the end of the presentation. Thank you all for listening. Peter, I invite you to jump in if I've missed anything in that last bit that you'd like to add or further emphasise. Otherwise, I suppose we'll go to some questions.
No, thank you very much. I think that's it. Just think about us as an employer outside Portsmouth, where there's lots of roles or lots of opportunities to continue to develop. So you don't have to come onto one of the graduate programs. We do have roles available for engineer ones, associates to come in and to start gaining skills and gaining experience with a company who want to continue to let you grow and want to help you develop and continue your career. But thank you very much, and thank you, Emma, for the presentation.